Good morning and afternoon, everyone. Today, I'm excited to discuss how InterSystems IRIS can be used as a healthcare data infrastructure. Chinese government has released a lot of policies for data-driven economy during the last years. In 2022, the government released guidelines to define data property rights, emphasizing secure and efficient data circulation. In 2023, the Data Elements and Action Plan targeted 12 industries, including healthcare. And in 2024, the National Data Infrastructure Initiative outlined key components like data circulation facilities and computing power bases. These milestones reflect a clear trajectory. China is systematically transitioning from data ownership frameworks to actionable strategies for data-driven innovation. By prioritizing infrastructure, cross-industry integration, and security, the nation aims to unlock data's full economy potential. Despite these efforts, a critical question remains: what exactly is a data utilization facility? What problems is it supposed to solve, and how? The need for mass production are fulfilled by assembly lines, just as what we done on automobile industry. We see the data production pipeline here. There are data resources from producers, there are assembly lines where data assets get processed, and the data products. There are services or data sets for consumers. But obstacles immediately arise. Data producers and processors lack a shared understanding. They struggle to align on what data is received. Data processors face another hurdle. Without proper toolsets to build products from data assets, they can't confirm if their assets meet requirements. This gives miscommunication between producers, processors, and missing tools for processors block efficient mass production of data-driven products. Now we can introduce File to help. As a data model, it evaluates raw data's quality, quantity, and value, while building reusable data ingestion components. As a data asset, it enables repeated data use and rapid sharing. By acting as a universal language, File aligns data producers, processors, and consumers, eliminating communication barriers and tool shortages. This makes efficient, large-scale data production achievable. As a well-known healthcare data platform, InterSystems IRIS for Health is capable to solve a lot of these problems with File. Now, let's explore the InterSystems IRIS for Health features. Let's see how IRIS address healthcare data challenges across three key areas. The first layer is data management. It guarantees security, supports HTTP for real-time transactions and analytics, and offers multi-modal storage. File repository solidify it as a robust data foundation. Together, these features empower healthcare providers to unlock data's full potential. The next layer is interoperability. IRIS is known for its interoperability toolsets. Adapters integrate diverse systems, transformation tools like data model, terminology mapping, bridge gaps between siloed systems and industry standards, such as HL7v2 or CCDA. Easy to use business process automates data flows. And finally, there are a lot of data utilization tools. With tools like analytics for insights, AI and machine learning for advanced predictions, such as image AI and plus File, and the data projection capabilities like File Secure Builder. It ensures data drives action. File APIs also enables seamless data sharing. IRIS simplifies data pipeline creation. Inputs like EHR and lab data are processed through file validation, transformation, and quality control using file-based business process. With multimodal storage in the middle, users can store file data assets along with their local knowledge or derived data in the same storage without the need to build a complex technical stack. And the output, uh, the user can get ready-to-use data assets, analytics dashboards, and AI-driven applications. This framework illustrates how IRIS streamlines the data journey from sources to products while delivering tangible advantages. First, look at the assembly line structure. The quality control process built on interoperability ensures fast build and manageable data intake. IRIS provides adapters and transformation tools, whether it's validating data or managing business process like master data management. IRIS simplifies intake, cutting down time and complexity. This directly reduces data processing costs. Next, the unified assets storage. Here, IRIS leverages file standards to store assets like patient, condition, and observation data. Without with multimodal storage and vectorized knowledge, it creates a centralized, standardized repository. This unity ensures data is consistent and reusable, forming a robust data production infrastructure. And finally, are the utilization facilities. They enable on-demand data delivery, which is very important. Tools like File APIs, SQL Builder, Analytics let users access data seamlessly. Need to share data? You can have data APIs deliver it fast. Want insights? Analytics provide real-time analysis. This on-demand delivery boosts data production efficiency. In essential, by building data assembly lines with IRIS, healthcare providers achieve a streamlined workflow, efficient intake, unified storage, and flexible delivery. The result, reduced processing costs and improved production efficiency, turning data into a scalable, actionable asset. Just like this. As we can see, with the toolset, we can reduce data processing costs dramatically. And with the tools to deliver data to a consumer, it improves data production efficiency. Let's just have a look at some example. This is a data intake process. Suppose we have an API registering patients into the repository. The patient interface collects details like patient name, gender, address. We can rely on the easy-to-use process editor to implement it. It visually outlines the workflow. It converts REST data to file via REST to file transformation, validating data against file constraints. If validating succeeds, it triggers a check patient similarity check. This drag and drop editor simplifies design complex data processes, even for non-technical users. During the process, the visible data transformation tool maps source fields such as first name to file patient resources, ensuring standardization. When validation fails, it provides error messages using file as a quality measurement. For instance, in this arrow, it highlights constraint violations, empty patient name, proving file's role in maintaining data quality. In essence, this example shows how IRIS simplifies data intake, intuitive interface, vision workflows, and file-driven quality checks ensure accurate standardized data processing. Let's dig further to see how IRIS extends file process capability. The visual workflow editor simplifies extending file workflow. We add tasks in default file API to add a patient. If patient posting succeed, it triggers makes embeddings, which extract patient features and generate corresponding vectors. As we can see in the code snippet, the top code uses IRIS SQL to insert patient data, including resource ID, patient name, etc., into the model, even handling vector conversion. The bottom code queries similar patients utilizing vector operations. There is no need to integrate external vector DBs, as IRIS natively supports vector processing, reducing complexity. Thus, we can have this result. The similar patient list panel shows practical results. There are resource IDs, patient summaries, and similarity scores. For example, the 88.9% similarity. This exemplifies IRIS enhancing file workflows with vector capabilities. Plus, the portal feature to other file repositories ensures this solution adapts seamlessly across different file environments. In this sense, by combining editable file processes, integrated vector support, and portability, IRIS can help streamline data intake analysis with cross-platform usability. Now let's look through a typical analytics use case. Look at the right. We need to generate critical KPIs that every Chinese Tier 3 hospital must report as in analyze the result. Like the first one is the ratio of outpatient visits to inpatient discharges, and third on surgery rate among discharged inpatients. These metrics are vital for compliance and operational improvement. With the help of IRIS File Builder and the InterSystems Business Intelligence, the process making the KPIs is kind of straightforward. First, we pick out related file resources and its fields to automatically generate relational tables. Thus, file is no longer a data model, but also the assets storage we can make use of. Then we can use business intelligence to compute measures from the generated relational tables, as illustrated in BI architect in the middle. That's a typical process using BI, that how we can obtain computed indices from existing facts, right? And finally, with pre-computed indices, we can then use analyzer to slice the measures with necessary dimensions, such as years, visit types, and to obtain the required KPI. That's to say, the combination of file repository, SQL Builder, and InterSystems Business Intelligence, the user can benefit from domain-specific data product delivery with reusable data assets. In short, IRIS is powerful, making meaningful analytics. It's about turning complex data into clear, report-ready insights efficiently. This is another example. We know that file was published with a lot of REST APIs, which makes it possible for applications to direct retrieve data from the repository. We can see two examples here. One is on the left is a CDSS application using patient lab results and the demographic field to compute his risk of cardiovascular disease. The right one is an application gathering data and put them into a patient-centric view for physicians, which is a very popular requirement when Chinese hospitals build data centers. As we can see, all these applications can be easily deployed with file search APIs. Thus, developers can concentrate on business logic instead of taking huge effort in building integrations every time a requirement emerges. So far, they are just the examples of how IRIS can help in data circulation. As a solution, let's take a look at the business part. We have seen a lot of data centers built since 2010s. Unfortunately, they are not enough to promote massive data production. For policymakers and health groups, IRIS hereby offer data evaluation using file-based quality assessment. We also provide asset monetization. Thus, data processors can convert data swamps into reusable assets. We also can have rapid service deployment using file. Then vendors can launch public services like lab result sharing in weeks, not in years. In conclusion, IRIS for Health is more than just a platform. It's a catalyst for data-driven healthcare transformation. Now I'd be very happy to answer any questions you may have. Thank you.